The time has come to talk about efficiency. We're going to be seeing efficiency in a couple different forms in the next week. And it would be worth considering exactly what efficiency is. Efficiency is really quite simply, I mean, this is just a verbal way of explaining it, but it's, we use eta for it, and it's what you get over what you pay for. Okay? Now, in the case of an engine, what you get is a certain amount of work. Okay? It's what you want out of the engine. What you pay for is how much heat you put into the engine. Okay? The heat that comes back out, you don't get to do anything with, so that's wasted. So what this basically measures is how much and what fraction of the energy, basically, is gone to what you want to go to. One way to look at this is to think of an engine as working between a hot reservoir and a cold reservoir. So heat comes out of the hot reservoir into your engine. Some of it goes back into the cold reservoir, making the arrow smaller in this case, and some of it goes out as work. The first law of thermodynamics, coupled with the fact that the engine should be on a cycle of some kind, says that delta U equals 0 because it's a cycle. So that's equal to Q in minus work out, which implies that this is the net Q in. So this is really Q in minus Q out equals work out, just rearranging this equation. What this tells us is the heat in minus the heat out is equal to the work, or if you prefer, the work out plus the heat out equals the heat that came in. And this is just conservation of energy at all it is. Efficiency should always be between 0 and 1. If you find yourself with an engine with an efficiency of 0, you done goofed. That is a terrible, terrible engine. Do not use that engine. The second law of thermodynamics, the version that we're going to learn in class on Tuesday, simply says that efficiency is actually never going to be equal to 1. There is only one condition in which you could ever get a perfectly efficient engine, and it also turns out to be impossible to achieve. The condition is that the temperature has to be absolute 0, and it also turns out that that is not possible. So there are other ways to look at efficiency. I mean, other situations where you could talk about efficiency. And we're going to encounter a bunch of those. So always when you see efficiency, think, what am I trying to get this thing to do? And what am I putting into it to get it to do those things? Okay. I feel like there's one more thing I wanted to say, and I've forgotten what it was. So next up, I'm going to show you Carnot efficiency.